Hello, greetings to everyone. I will present in the first virtual European Conference on Fracture the work with the title Bonded Structures Improvement by the Dual Adhesive Technique. This presentation is divided in the following topics. First, goals or objectives. 2. Small introduction to adhesive stepped lap joints. 3. Experimental work and numerical work, where all the materials and properties will be shown as well as the results. And 4. Main conclusions. Topic 1. Goals or objectives. The main objectives of this work is to perform an experimental and numerical study of aluminum stepped lap joints composed with two adhesives for various overlap lengths, predict the behavior of the joints by the application of finite element method through the triangular cohesive zone model, joint strength and failure energy analysis, and finally perform a comparison of the dual adhesive with the single adhesive joints. Topic 2. Adhesive bonding. The stepped lap joints are characterized by the decrease of the stresses variation along the adhesive layer. The main advantages of this kind of joint is the decrease in the peel load force and the decrease of the stress gradient. Their main disadvantages are the difficulty in machining, bigger manufacturing time, and more expensive manufacturing process. Joints with two adhesives or mixed joints are joints that can withstand high and low temperature applications. They try to improve the stress distribution. A stiff adhesive is normally used at the center of the joint, and a more ductile adhesive is used at the ends of the joint. Topic 3. Development, and is divided in experimental and numerical work. For the adherence was chosen the aluminum alloy AW6082 with a heat treatment. And the adhesives selected are the heraldic AV138, which is an adhesive with high stiffness, and the heraldic 2015, which is an adhesive with moderate ductility. The dual adhesive configuration is to use heraldic 2015 at the joint's end and at the center the heraldic AV138. In this slide is shown the manufacturing process stages of the adhesive joints. The adherents are cut, then the fillings or the excess material is removed. After, we machine the steps and perform the adherence surface preparation. After, we do the application and cure of the adhesives, then some post-cure finishes, and then the tensile test. Here is shown the without experimental results for the dual adhesive configuration. Graphic A is for an overlap length of 12.5, B for 25, C for 37.5, and D for 50 mm. Overall, the results are very consistent with the exception of the overlap length equal to 50 mm. Here, the Pmax values are in good agreement, but if the displacement test failure exhibits some differences, probably this is due to some slipping in the testing machine. In slide 12 is presented the evolution of the average Pmax as function of the overlap length. It is possible to observe a Pmax remarkable increase for overlap lengths of 12.5, 25, and 37.5 mm, and a small increase for 50 mm. Also, the standard deviation values are small, which indicates very consistent results. Now comparing the dual adhesive with the single adhesive configuration, it is possible to observe that overall the best adhesive configuration is the joints with the single adhesive heraldic 2015. Also, it should be emphasized that the use of mixed joints is only favorable in particular cases, because the combination of two adhesives may increase or decrease the bond strength depending on the overlap length. The failure energy is obtained through the area of the P delta curve. The maximum failure energy is the product of the forces with the variation of the displacement. Here it is possible to observe an exponential increase of the failure energy with the increase of the overlap length. Again, small values of standard deviation are obtained. When comparing the failure energy between dual and single adhesive configuration, the configuration that presents higher energy is the single adhesive RLD 2015. The classification of the adherents causes a remarkable increase of the failure energy, as is the case for an overlap length of 50 mm and with the single adhesive RLD 2015. The numerical work was performed in the finite element method software AVA. The numerical analysis condition stages are first the joint design, then definition of materials, after material properties assignment, for definition of the boundary conditions, then implement the analysis conditions, after mesh assignment, and then analysis of the results. Comparing the numerical results with the experimental ones is possible to see a satisfactory agreement, being the minimum difference 3.1% for an overlap length of 37.5 mm and the maximum difference 15.1% for an overlap length of 12.5. The stepped lap joint strength comparison between the dual adhesive with the single adhesive configuration is performed in this slide. In the numerical results, the minimum difference is minus 10.5% when compared to the single adhesive RLD 2015 and for an overlap length of 50 mm. The maximum difference is 31.2% in regard to the single adhesive AB138 and for an LO of 37.5 mm. Regarding the experimental results, the minimum difference observed is minus 18.6% when compared to the single adhesive AB138 and an LO equal to 12.5. The maximum difference is 30.3% in regard to the adhesive AB138 and an overlap length of 37.5 mm. Now presenting the experimental and numerical comparison of the failure energy evolution as function of the overlap length increase, it is possible to observe a satisfactory agreement. The minimum difference is minus 13.7% for an overlap length of 50 mm and the maximum difference observed is 67.1% for an overlap length of 12.5 mm. Performing the failure energies comparison of the dual adhesive relative to the single adhesive, in the numerical analysis, the minimum difference observed is minus 28% in regard to the adhesive RLD 2015 and an overlap length of 12.5 mm. The numerical maximum difference is 66.3% when compared to the adhesive AB138 and for an LO equal to 50. In terms of the experimental results, the minimum observed difference is minus 80.4 regarding the adhesive RLD 2015 and overlap length of 12.5 mm. The maximum experimental difference is 75.2% when compared to the single adhesive AB138 and an LO equal to 50 mm. Topic 4. Conclusions. In this particular dual adhesive configuration, it is not possible to observe a significant improvement when compared to the single adhesive configuration. The use of mixed joints is only favorable in particular cases, because the combination of two adhesives may increase or decrease the bond strength depending on the overlap length. Overall was obtained a good agreement between the numerical and the experimental results. The plastification of the adherents also causes the increase of the failure energy. More brittle adhesives present bigger damage due to their lack of plastification ability. Thank you for watching.